So here we're just talking about updating database tables with embedded SQL after the user has input data into a program record using the input or input by name. So since we're talking about updating database tables with these program records after the user has input data into the form fields and we've updated the program records, then we're going to use that information in the program record to in turn update the database table. Anytime that you're working, especially with grouped SQL transactions, for example, let's say that we're working with the account table and we're letting users update account information, and then maybe we're also letting them update order information, kind of in a grouped set of SQL transactions. It's always a good idea if your database supports transaction logging, or transactions we can say. It's always a good idea to use transaction blocks to group these multiple SQL transactions. And the idea there is if we use these special transaction blocks, begin work and commit work, what that does is just ensure at the database level that either all of these multiple transactions are committed to the database or none of them are, right? They're all rolled back. For example, let's say I wouldn't want to have a user enter order information and then some separate line items for that order that are in two different database tables. Let's say the orders are in one table, the line items in the order are kept in a different table. I wouldn't want the user to get through entering an order and then the system fails, it crashes, and the order information gets sent to the database but not the individual items for that order. And using transactions, transaction blocks, begin work and commit work, I can make sure that happens. If the user has, let's say, a system failure, network goes down or something like that, right in the middle of his updates, then it will make sure at the database level that it rolls back the entire group of transactions and we don't end up with like a partial set of transactions completed. So either everything gets done in the SQL statements or nothing gets done with these database transactions. So that's what we're seeing here is an example of using transaction blocks in some code, and we'll see that in our actual debugger session as well. So here we've got a begin work which says that everything between this begin work statement and the commit work statement, we see this down here at the bottom, needs to be in a single set of transactions. It all needs to be committed or none of it needs to be committed. It needs to be committed as a group. So at that point essentially it's using locks to make sure that the locks aren't released on any of the rows affected by the transaction until everything has been released with this commit work. And if anything happens in the middle here, right, where he's going along and it gets maybe down to this point and it fails, then everything he's done so far since the begin work statement will be rolled back by the database server. All right, so the database server takes care of kind of backing out of any transactions that have been done since the begin work but before the commit work. So here we've got our update statement there. Looks like we're just doing what we would call a singleton transaction here. It's just one, looks like one statement in here, this one update. It's not really that important when you're just doing the one update of a single table. It's usually whenever you're working with transactions that affect multiple tables that you're really concerned about using transaction blocks. But it's a way to get started with it. Right here we've got a begin work, we've got an update statement, and if everything is okay with the user, continue okay equal true, he's happy, then we have a commit work. And that goes ahead and commits that update to the database. At that point, you can't roll back out of the transaction. Now notice we do have a rollback work statement that you can use, and you could put the logic for that in here. For example, if continue OK equal false, so we ask the user if he's happy and he's not happy for some reason, then we could put the rollback work in the code there if he's continue OK equal false. So we can use that to manually roll back transactions if we like. All right, so here's an input statement to add a row. So here we've got a function that we're able to use for adds. If we want to add a row of data, we're using this function, but we're also using the same function for updates. So it's kind of a multi-use function. And the way we're doing that is by passing in a flag, this AU flag. It's just a variable defined as a character 1, and the value of that AU flag will either be A, right, which means that the user has selected the option to add a row, so we're using A for that, or it can be U if the user has selected the option to modify a row or update a row. And so we call this function and we pass in either an A or a U, and that determines whether or not this function is used for an update or just an insert, an add. So one thing we'll look at is we have a work record defined here. When we look at this application, we're actually using multiple program records. They're all identical program records, but we're using these different records for each one has a different purpose. So this work record here, this work underscore account rec, we're going to use that for a special purpose during an update especially. So that's when we'll really focus in on this. Right now we're just initializing it to null. If the AU flag passed in is an A, if the user select an A, we're going to give the user a message that we've got the add a new account has been triggered here. And then we're going to have our program record. This is our modular level record that we usually use for inputting the values into in an input statement. We're going to set that to null as well because it's an add. And we're doing that by just taking this work account record that's already been initialized to null and setting this MR account record, all the members of it equal to the members of the work account record, just nulling it out, right? So we're initializing it so when the user does his input, everything in there will be fresh data from the user input. And then when the user's finished doing his input, we're using this input by name. This MR account rec is our program record that we're using for the input without defaults, and we're using our unbuffered attribute that we just talked about. So there we are letting the user at this point input all this new data into a program record called MR account rec. This is focusing in on some control blocks. We've looked at control blocks and used control blocks a bit already in class, but they're very powerful because control blocks let you control what the user is able to do during that input instruction. All the interactive dialogues have control blocks that let you control user interaction with the screen and with the input statement and with the form. So here it's saying on change user ID. That's one of our control blocks that we can use. If AU flag equals A, then select user ID, email, phone into MR account rec.star from account where user ID equals the same user ID that the user just input. So what this is doing is immediately after the user inputs the user ID, that's the primary key for this account table. As soon as he enters the primary key, this onChange block has the logic in it to go out and do a select statement to see if a record in the database already has a primary key that matches. And of course, if it does, we're not going to allow that user to re-enter a duplicate record, right? We already have a record for that user. So this is kind of nice because it keeps that user from going through the whole process of entering the address, the zip code, the phone number, all this extra information if he's already got that record in the database. So it comes right back and says user ID already exists. It sets that continue OK flag to false, and then it goes right back to the display account function. right? It exits out of the input statement. So that keeps the user from entering in a bunch of data, and the insert is going to fail because that record already exists, right? And it won't let us enter a duplicate record for that primary key. So that's one example of using a change block to help out the user and keep him from making a mistake that'll cost him some extra time. So here's the insert statement. What we've seen so far is the user using that input statement to enter new data into the form. That new data has been updated to the program record, and now we're going to use this function to actually go in and update the database table, the account table. So here we've called this insert account function, and we're just using the very simple SQL, embedded SQL here to update or insert this record into the table. Insert into account and then all the values here, essentially right out of the program record, mr account rec.star. And then we're checking the status. If you remember from, I think it was the day before yesterday, we talked about this special built-in record, this SQLCA record, and I think we talked about it some yesterday as well. So we're checking the status of this SQL code member of the record, and if it's 0, that means that this insert was successful. Otherwise, we're displaying another member of the record, this SQL error message, so that he can see what went wrong. So that's the input and adding a row with the input statement, and we saw the insert statement that corresponds with that to update the database table. And now we're switching gears a little bit, and we're moving on to updating an existing row. So we're not putting in new data, we're modifying an existing row of data. So to modify an existing row of data, we're going to use an update cursor, and here we're talking about a proprietary I'd call it a parameter or an attribute for update cursors that's proprietary. I know that Informix supports update cursors withhold, and the purpose of the withhold parameter or attribute for an update cursor is to keep the result set of the cursor open even after the transaction has been committed. And the idea there is the user can go through the result set after doing a construct, right? You let him do a query by example. Maybe he selects a result set of rows from everybody in London, let's say, and then he's able just to use his previous and next buttons to scroll through the result set and make changes. So he makes changes to one record. He's still able, after he commits that, to move on through the result set and maybe update another record. So that's the benefit of the withhold. Database servers that don't support this withhold option, basically as soon as they, let's say, insert a record or modify a record, that commits the transaction and that releases the locks, and then it also closes the cursor at that point. So when he gets ready to look again, or if he has some more rows to update, he's going to have to do a query again to bring up that result set. So that's the benefit of using the withhold. Unfortunately, it's not portable. So I can't really say it's a best practice to use the withhold. It's very convenient for the user for you to use the withhold, but since most databases don't support it, it's probably not a great idea. All right, so an update cursor puts an exclusive lock on each row as it's fetched. Now, this is also called pessimistic locking. The idea here is we're pessimistic because we're afraid that some other user out there is going to try to update or lock the same row that we're interested in. So we're going to beat him to the punch. We're going to go out there and lock this row exclusively, and we're going to keep that lock until we're through with that row, either by moving forward and fetching another row or by committing a transaction. And then we'll release the exclusive lock on that row. So that's pessimistic locking. We're afraid somebody else is going to get the lock on our row, so we're going to lock it first, exclusively. So The advantages to that are that, of course, nobody else is going to be able to touch that row or do anything but look at it until we're through with it. So that's the whole reason for using an update cursor. The disadvantage is if you've got a lot of users out there and they're all using update cursors all at the same time, you can see where it can cause concurrency problems. So you'll end up with some users waiting on other users because those users are scrolling through these rows using these exclusive locks that come with these update cursors. So that's probably the biggest disadvantage. The rest of this is just kind of incidental, I think. The cursor select statement, you can't use an order by with it if it's an update cursor. It's also limited to a single table, and it can't be a scrolling cursor. But the big concern is this first one, concurrency problems. Those update cursors use exclusive locks, and if you have a lot of users, you can have people waiting on other folks to release those locks, and they think that something's wrong. They think the program is hung or stalled, and your support folks start getting phone calls. So here's some of the logic for an update cursor. So for databases that support transactions, you'll want to declare your update cursor outside the transaction, but open the cursor inside the transaction. So they're talking about the begin work, right? So here they're declaring a cursor outside this begin work before it, and then they're opening the cursor inside the transaction. And here it's saying, okay, that's going to grab an exclusive lock on each row as it's fetched, and it'll release that lock if you do an update or if the user does an update. And when the update completes and commits the work, it's going to release that exclusive lock. Or if the user doesn't update that row and he fetches the next row, that will in turn release the exclusive lock on the previous row. If your database doesn't support transactions, it goes ahead and releases the lock anytime the cursor's closed or as soon as the next row is fetched. So here we're talking about another way of doing an update without using exclusive locks. Well, we do use an exclusive lock, but only for an instant, right? We only use an exclusive lock, and that's when we actually do the update on the database table itself. All this scrolling through the rows using a cursor, fetching one row at a time, and putting an exclusive lock on it is not done with this method. We do scroll through the rows, we're just not using an update cursor. Over here we're talking about this for update cursor. That's the part that's putting the exclusive lock on the row. With this method, we're not going to use an update cursor. We're just going to use a method that doesn't use an update cursor. So we'll look at the rows, but we won't put an exclusive lock on them. So the advantages to this method, as you can imagine, it's called optimistic locking because we're not actually doing any locking until the actual update takes place. So we're being optimistic because we're assuming the users won't be grabbing our row while we're trying to work with it. So we're being optimistic. We don't think we're going to have a problem with somebody else locking our row. So we get better concurrency than if we use an update cursor, but the disadvantage is it requires more code. Right? The coding is a little more complex, and we have to keep checking before we do an update to make sure no one else has gone in and locked our row or made a change to it or deleted it. So that's what they mean by retry logic. Requires more retry logic because we can't be sure that no one else has locked that record and made a change to it while we're doing our input, for example, because we don't have it locked exclusively. So updating an existing row with optimistic locking. To use optimistic locking, we do have to have more retry logic. And one of the ways we handle that is using the special additional program record that we're calling a work record. We also have a local record. So basically, what we're saying is we're going to have 3 different program records that we use for optimistic locking to keep from putting an exclusive lock on these rows for the entire duration of this user input and transaction so that we can give our users more concurrency. So the work record is going to be used to hold a copy of the row before we change it. It's the original values of a row that we're going to update. We're going to store a copy of it in this work record and leave it out there for the entire duration of our input statement. And then right before we do the actual database update, after the user's finished his input, we're going to use this local record. We're going to select the row again right before we do the update from the database table, select it into the local record, and then we're going to compare the local record with the original values of that row in the work record and see if they still match. If they still match, if they're identical, that means that our optimism paid off, right? Nobody has been in there and deleted that record since we started working with it, and no one has gone in there and changed it. So that means that we're free now to go ahead and do the update. But it does take 2 additional records to do that. One that sits there holding a copy of the, we'll call it the before image of that row. As soon as we select it to update it, we put a copy of it in the work record. And then once we're finished inputting the new values into that record in the regular program record, then we're going to do a select that row again from the database table and store it in the local record, compare the two, and make sure they're still identical. And if they're identical, then we go ahead and update the database table because no one else has done anything to that row. Hopefully that makes sense. I know it's a lot to keep up with. So we use a scroll cursor, right, but not an update cursor, just a scroll cursor. So it's not using exclusive locks. It's just using shared locks. Allows the user to scroll through the results set. When he picks modify, the values in our program record are copied to this guy. Then we go ahead and do our input, store it in the program record, and it's a separate record from either one of these we're talking about up here at the top. We use the without defaults, right, because the user is being allowed to input the data. We don't want to override that with defaults from the database. And then an update or update cursor uses the primary key in the program record to select the same row into the local record. So the users input the data. Now we're going to go ahead and grab that row that we're updating and put it in the local record. Then we're comparing the local record that's done the fresh select with the copy in the work record that was selected before we started to see if there's any changes. And if there's no changes, then we go ahead and update the table. So if the withhold is used, which remember is proprietary, most of the database servers don't support that. It's primarily an Informix option. Then we can have the scroll cursor stay open and the user's able to still scroll through the result sets, look at more rows, and make changes to rows. But that's just for certain database servers like Informix. All right, so I think right here I'm going to stop going through the PowerPoints because you can see it's just a bunch of screenshots of code from this point. So instead of looking at it there, let's just go ahead and look at it in person here, or real time. So we've got an accounts application here that's got the same logic that we've been talking about and looking at. So I'm just going to use the debugger. Go ahead and pop up the debugger here. And this will give you some more exposure to it and maybe see the value of it. I like it a lot for doing things like this to try to figure out what a complicated application might be really doing. Here we are, we've got this accounts application up, and let's go ahead and start out with an add, right? Since that was how we started this module, with adding a row to the database using that input statement. So I'm going to click add. I'm going to have to bounce around a bit. Well, let me back up here. Let me kill that so you can see the menu statement. So I'm starting over here. All right. So that puts us here. Now notice up here at the top, this is something that's good to know how to do. Yesterday we talked about this looks like a pause symbol on your remote up here in the toolbar. This is essentially the interrupt, so I can see where we're at in the code right here. You can see that we're in a menu statement. So I want to see that code, so I'm going to hit interrupt here. Remember yesterday we said there's a couple of ways you can start these debugger sessions. One of them is like I just did it. I just started the application. When it got to an interactive dialogue statement, this menu statement, I had the option to hit the interrupt. So I hit the interrupt, and that put me to that point in the code. All right, so here I'm sitting at this menu. So here we are in this application. We're kind of up at the top. Here's the main program block, and we're sitting here in this menu. So now I'm going to go back and hit the Add button again. I want to add a row. And then over here I'm going to hit this Next. And you can see where we went to in the menu. All right, so on Action Add, I'm right here. Looks like I'm going to call a function called, oops, that didn't look good, does it? Input Update. I'm going to call that INPUPD, INPUPD underscore account. And when I call that function, I'm going to pass it the literal value A. All right, so that's our flag that we're using to tell this function that we want to add a row. Now notice right down here, on Action Modify, we're using the same function again. If input update underscore account, and we're passing it a U, right? So we're going to pass this same function either an A or a U when we select these menu options. If we select Add, we're passing it an A. If we select Modify, we're passing it a U. So we're using the same function for two different things, inserts and updates. So we're going to call this input update account and see if it is true, and if it comes back and everything looks good and it's okay, then we're going to call another function called insert account to update the database table. So first let's go look at what happens in this input update account. So I'm going to step into it with this option here in the toolbar. So here we are in this function, input update account, and we've passed in an A, right? This AU flag is an A, and we have assigned that parameter to this local variable AU flag here. So the value is A, or it will be shortly. Before we go any further, I'm going to scroll up to the top though and let you look at these records. Remember how we were going through the PowerPoints a few minutes ago and we talked about using optimistic locking and how that required some additional records, program records. So here they are up here at the top of this second module, right? Notice that we've actually opened another source file called accounts mate. Here's our schema statement, and right here we're defining two more program records. MR account rec, MR account rec's our normal program record that we'd be using for the update, but here's this work account rec record, and this is the record that we're going to copy the row into at the beginning of our update, right? Before we actually touch the row and let the user do his input, we're going to copy the contents of that row in here and keep a copy of it while he does his update. And this other program record is the one we're going to use to store the values that the user inputs. In a few minutes, though, you'll see another program record. It's typically called a local program record because it's going to be local to this function. All right, so let me pop back down here to where we were. I just wanted you to see that we did have this work record that's identical to our program record here. So here we are in our function. Let's go ahead and click Next here. So here we're initializing this work record to nulls. And now down here in the data view real quickly, notice that this AU flag here is an A for add. We're setting continue OK equal to true, and this is what determines whether or not we go ahead and go on and call that next function to insert the data later on. So unless this gets set to false, we're in good shape. Here we're checking this flag. If AU flag equals A, which it is, right? If we look in our data view, it's equal to A, then we're going to give the user a message, add a new account, and then we're going to set our MR account record, the contents of that record, equal to this work account record that we set to nulls up here on line 169. So all we're doing is initializing that program record so that when the user inputs his data, it will all be fresh data. All right, so that's what we're doing there, getting ready for him to do his update. Then we're setting our int flag to false, if you remember that from yesterday. That way if the user presses cancel during this input, we can gracefully cancel out of the input and let him gracefully exit if he wants to, or start over. All right, so here's our input statement. We're getting ready to turn control now over to the user to enter values into our screen record, into our form, and that in turn will be updating our program record, mraccountRec.star. Here's our without defaults and our unbuffered attribute that we talked about that makes that input sensitive so that as the user enters data into our form fields, into our screen record, it's automatically going to update our program record with these new values when it leaves the field. So one more next up here, and look what it's done here. We should be in our input, but we have a control block here, a before field control block. Before field user ID. Now that's our primary key for the account table. So it says before the user enters the primary key. If AU flag equals U, in other words, the user has selected the option to do an update, modify, then go on to the next field, email. So in other words, if the user's doing an update, we don't want him to be able to change the value of the primary key. We're making him go on to the next field in the record, which is email. Not allowed, that's a common thing, right? We don't usually want people to be able to modify a record and change the primary key. We'd much rather for them to just delete that record if they're going to change the primary key and enter it as a new record, right? It would be a different record at that point. So here's our input by name. And now it's under the control of the user. And I can tell that because I've got this interrupt symbol. So it's just kind of ignoring me because now I'm waiting for the user to do some input. So here I am. I'm the user. I have access to the user ID field because I selected A, right? I selected the option to add a new row. So I'm just going to make up some stuff. And notice I can't go on to the next field here with the debugger because there's some more logic getting done here, some more logic being executed. So I just changed the user ID field, right, by typing in CHILDRE. So here is another control block that detected that change to this field. And it says, uh-oh, if the AU flag equals A, then whenever error continue, select the user ID, well, cut to the chase there and say it's going to select all the values from the account table for that row and put them into our MR account rec record. So this is what we saw in the PowerPoints earlier. We're doing a select here to make sure that I'm not accidentally entering a row that already exists. So it says if the SQL code is 0, then the user ID already exists. So let's go down here and look at our data view. Row looks like I have, right? 0, SQL code 0, yada yada. So I may be in trouble here. User ID already exists. Let continue OK equal false. Call display account and exit input. All right, so I've got some logic in there now to make sure that I don't enter a duplicate row. So it put me right here so that I have to start over again. Go back to the menu. There we go. All right, so I've messed up there with that one. Okay. All right. Bear with me here. I have to do it one step at a time till I get back where I want to go. All right, so already got that record in there. So let me pop it to the next part so that you don't have to walk through all of that again. There we go. All right. So I will use my cat. All right. So if AU flag equal A, we'll repeat here. I'm going to select this row, or try to select it into my program record, and check my status of my SQL code and see if it already exists. And notice this time the SQL code is 100. Anybody remember what 100 is? That means not found. That's kind of that predefined not found value. So this time I've entered a record that doesn't exist. That's good if I'm adding. So now I'm back in my input statement. So let me pop this in here real quick. I'm just going to enter some junky stuff here so that we can Here's a combo box. I was going to show you that, so when I get through I'll try to remember to review the combo box again. Another combo box. All right, so now I've got my data entered. I'm going to click OK. Let's see where we're at over here in the code now. So if int flag, which I didn't interrupt, so it ought to skip right over that. And it says OK, return OK, continue OK. So we're going to go back to our calling function. And if you look down here in the backtrace view, we're going to go back to main. All right, so we're back in the main. And here we're back in on action add. We're back in our menu statement because we finished running all the code in this input update account with this A that we passed to it. So now we're ready to actually update the database table with the contents of our work record. So let's see what that looks like. So we're going to step into this function insert account. So here the first thing we're doing is inserting into account the values of this MR account rec. We're checking our SQL code, make sure it worked okay. We'll go down here, look at our data view again. Looks good, right? It's a 0. So it's going to tell me a row was added, and then we're just going to go back to the menu. So that's the logic for an add, right? Just to kind of walk through that. And down here, here's my message, row added. So we're back in the menu. This time, let's go ahead and try an update. Step forward here till I get control back as a user. All right. So I'm going to do a query. Just going to select all rows. And I think I'll change Jean DuPont's city back to London here. All right, so here I'm going to do my modify to change the city for this fella. So here I'm hitting modify. And then right up here, well, fiddlesticks. I went one step too far so that you didn't get to see the menu, but let me pop back over there. All right, so a second ago I hit modify, so it went to this line right here, on action modify. If input update account U, then call update account. So in other words, it's going to call this input update account function and pass it a U. All right, so that's where we are now. We're in this input update account. We've passed it a U. If you look down here in the data view, here's this AU flag equal U right there. Just to catch you up, I must have hit next twice when I shouldn't have, so we went a little too far. So here we are, and we're initializing this work record to null, just like we saw earlier with the add option. We skipped right over this logic for AU flag equal A this time because it's not an A, it's a U. So we're getting the message update account, right? So else message update account. Let the work account rec equal MR account rec. So let's see what we've got down here. Here's MR account rec. Has all this information about Jean DuPont in it. And right now, the work record is all null. So I'm going to go one more line. And now you see this work record has been updated with all the information from that MR account rec program record that we loaded with the data from that row. All right, so now we've got our, I'll call that the before image, right? This work account rec, we're just going to leave that before copy of that row in that work account rec. And this is how we're going to be able to tell after the user finishes this input. When he finishes and we're ready to update the database table, we're going to select this row again from the database table and we're going to compare it to this work record, right? That's going to sit here untouched while we do the input. So let's go on and look at that input. So here again we've got a control block. If AU flag equals U, then I'm going to make the user move on to the email field, right? We don't want him to be able to use or to update the primary key is the purpose of that. So one more it looks like. All right. Rats. Okay, let me explain what has just happened to us of all things. I used the temporary key just like you guys did when I did the install, and as it is a temporary key, you only have so long to run your applications. I guess that's their way of monitoring use of these temporary keys. So basically our session timed out and it blew up my application there. So I'm just going to run it again and just get down to that point as quickly as I can. All right. Here's our int flag, and now we're back to our input. That's where we fell out a minute ago. Get rid of that. There we go. Okay, so here we are in our input. One more step here. Here we are forcing me to go to the email field. Now I'm in my input. So here I'm just going to modify this row and click OK. And here we are going on to the next line after the input. I haven't interrupted, so it should pop right past that. Return, continue, OK. So now we're going back to our menu again, and we've just finished this input statement. So now we're going to call this update account function. So I'm going to step into that. So here we are in this update account function, and notice what we're doing here at the top. We're defining yet another program record. This one's called the local record because it's local to this function, called L account rec record. And notice it's just identical. It's got all the columns from the account table represented as members here. So let OK, continue OK equal false. We're just initializing that. And here we're going out right before we update the table. We're going to check to see if anybody else has gone in and changed or locked this row that we're trying to update. And the way we do that is we're just going to select it again, and notice we're putting it into this local program record. And here we're saying, okay, now let's check the SQL code. All right, so if it's not found, that means somebody else has already gone in there and deleted it while we were still trying to do the input statement to add values to the program record. But it's still there, so everything's good. And then it says else. Now let's compare this selected row that we just selected that's stored in this local program record, L-account rec, with what we put in the work account record a while ago before we did the input. And remember, if they're still identical, that means that it's fair game. Nobody else has, we know, has deleted the row, nobody else has it locked right now, and nobody else has changed it since we've been working on it. So let's see what happens. Looks good. If we look at them just real quickly, well, I was looking for my local, there it is. Okay, I was looking for my local record. I wasn't looking in the right place for it. Here it is. Here's the local record set to Dallas. And here's our work record that we need to compare it to, and it's still set to Dallas. Everything else looks the same as well. So everything looks good. They were identical. So if everything's identical, then we're going to go ahead and do our transaction. Begin work, and all we're doing here is updating the database table, the account table, with the contents of our typical program record, MR account rec. And if everything looks good, which if we look at our SQL code, looks good. 0 there. Let continue OK equal true. Give the user a message that the row was updated, and then we're ready to commit work. So if continue OK equal true, commit work, and then we're going to go back to the menu. Phew, all right. So here we are, and there's our message that the row was updated, and now we're sitting back at the menu. All right, so just one more thing probably to look at, and that's a delete here. So let's go ahead and do that while we're in the middle of this. So let's go ahead and query. Just going to select all rows, and I'm going to scroll forward until I get to that record that I put in earlier, and I'm going to click the delete button. I want to get rid of it. So have you look at that. So I'm going to hit this interrupt here to put us back in the code. All right, so look at what we're looking at here. This is a good way to get yes or no or confirmation from the user is to use this special dialog style for menus. We talked about that, I think the day before yesterday. There's only like 3 styles possible for menus. This is one of the few objects that you're not allowed to create your own styles for. And one of the styles that you can use is this special dialog style. And it's pretty nifty, right? It pops up just this little menu option on top of the other windows. That's what the dialog style does. And this comment is delete the row here that we see, and I can specify yes or no. So I'm going to say yes. And it says on action yes. So let delete OK equal true. And then return delete OK. And now here we've done this if delete check. That's where we were a second ago. And now we're calling the delete account function. So we'll step into that. And we're just going to delete from account where user ID equals our program record user ID. And then checking the status of our SQL code, which looks good. We got a 0 status for that. So we give the user a message, row deleted, and then we're going to reinitialize our program record and redisplay that so he doesn't have a bunch of stuff on the screen he thinks he's deleted. And that puts us right back to the menu again. So that row should be deleted. If I do a query now, it should be gone. And I don't see it. All right. So I know that was kind of tedious. That's about the best way I know of to show that type of code, all those different functions that call other functions and that type of thing, is to kind of walk through it with the debugger. All right, well, I think it's break time. This is a good time for a break. We've been at it about an hour. So I'm going to unmute you, and then we'll take a 15-minute break, and then we'll come back and do the array chapter, which is our last chapter today, and it's another nice short chapter. And then I will try to remember to review the lab from yesterday. I haven't forgotten yet. I have an answer for Norma while I'm thinking of it. Norma had a good question yesterday about does the first letter of the toolbar item have to be unique? And I tested that yesterday, Norma, and it looks like it does not, right? So I was able to create multiple toolbar items that started with the same letter, and I tested them and they seem to work just fine. So let's take a break. Let's say it's 10:05 Central Time, so let's come back at 10:20. So let's take a look at Module 10, our last module for today, on working with arrays. So by the end of this module, you'll be able to define a form to handle an array. We're going to work with a different type of container for that form than we've worked with so far. How to load and display an array and dynamically fill an array. Modify data in an array. And then there's some dynamic array built-in methods we're going to look at that make it a lot easier to work with arrays. Those methods are built into our runtime system with Genero. And then we'll talk a bit about control block execution order. So what is an array? We've talked about arrays a bit, I think, in the very first day when we're going through our overview of the BDL language. It's one of our structured data types, and an array is a series of objects of the same type and size. So here we've got an array over here on the left-hand side that looks like just a simple array of integers, and you can access a specific element in the array. All the values that you add to an array are referred to as elements. So if I want to access a particular element in an array, I can use an index. So if I use this index of 3 here, I should have access then to this value of 103, which is the third element in that array. You can also have an array of records. That's pretty common when we're working with database tables, to use arrays to hold records that represent all the columns in the database table. So here we've got the kind of the same type of syntax. We've got our index, but then we can use this dot member syntax to access a particular record and member of a record in an array if we want to. So this would be the third element in the array, and we're looking for the user ID member of that record with that particular syntax. So you can essentially have any kind of data type in an array, like an array of records, array of characters, whatever you like, anything I believe except other arrays, right? You can't have an array that's populated with arrays. That's the only rule that I know of. So to display an array, you've seen actually probably a lot of applications that are working with arrays. The orders application in our Office Store app has a big form container there that is choosing to display all the order items at the same type. And the way it's at the same time, and the way it's doing that is it has a special container defined in the form called a table container. We actually have 2 or 3 different types of containers that you can use to display a list of records, and that's what an array is, right? It's just a list of records. Instead of displaying one record at a time, if we want to show the whole array at the same time, or at least part of the array at the same time, we can use a table container for that. We can also use a scroll grid. A scroll grid looks just like a grid. We've used grids several times in class already to display a single record at a time. Well, a scroll grid looks just like that, except it comes with a scroll bar. So you could use a scroll grid container to display an array. You could also use a tree container to display a list of records, an array. So we have several different containers. By far the most popular type of container that people use to display arrays to is a table container. So you'll have your table container out there in your form And then you'll be working with a screen array. That will be your form structure that you will be displaying your program array to so that it's displayed to the form. So the users can scroll through the records when we use this display array statement. That's another one of our interactive dialogue statements that we've been talking about the last 3 days or so, the display array statement. So this display array statement comes with a lot of built-in features that you don't have to do any special programming to use. For example, when you display the array like this to a table like we see here, the users automatically have this built-in ability to go in and sort on one of the columns, right? They can click on a column to sort by it just by clicking the column header up there. Notice they can also hide and show fields in the table. Like if they don't want to see the, the item ID, for example, they can deselect it so that it's not displayed anymore. All kinds of nifty features there that come with the display array dialog instruction. A lot of our special features that we talk about in the other class, the class we have on working with the user interface that we have I think in November, we talk about a lot of these other features like drag and drop is a feature of display array. Multiple row select, where the users can go in and select multiple rows and manipulate them, is a feature of a display array. So a lot of functionality built into that. All right, so here they're defining the form, or talking about defining the form, and we're talking about the screen array. When we display an array to the form, to a table, essentially we're displaying it to a screen array, and it's just a repetitive array of fields. And each row, grab my highlighter here, it's being kind of stubborn, each row of a screen array is a screen record. Right, and the screen record you can see over here on our right-hand side over here in our structure view, you can see the screen record definition here. So if we use the create form from database wizard, if you use that wizard that we've been using to create forms and you pick the table container for that, it will automatically create this screen record for you that accounts for each member of, well, basically whatever columns you've selected, right? The first step, the first dialog of that wizard is to select the database, table, and columns that you want represented on your form. So if you've used a table container for that, it will automatically create this screen record for you like this. If you were using a per file, though, of course, you'd have to define all of that manually. So in a per file, the text-based file, form files that we've looked at a few times, you would have to define the table layout in the layout section of the form, and then you would have to define the screen array down at the bottom of the form in the instructions section. So that's all manual when you're working with these text-based forms. That's one of the nice things about Form Designer. It does all of that automatically based on the columns that you select and the type of container that you select. So here we're talking about using an array with a database, just the steps that we would go through in the code to populate an array and then use that array to input data into the database or otherwise modify the data in the database. So first step, of course, would be to get a database connection anytime we're working with a database. So that's the first step here. We're going to use a cursor or define a cursor and use a for each statement to retrieve a result set from the database and use this for each instruction to fill the array with data from the result set. And then we've got our program array now that's filled with data, and we can use this display array instruction or input array instruction to display data to our tree or table container or scroll grid container in our form. Now, if we're just wanting the users to be able to look at data, we would typically think of using the display array instruction for that. But just FYI, the last several versions of Genero, we've had some additional functionality with the display array instruction that actually allows the users to insert, update, and delete data in an array as well as just look at it. So we can still use the input array instruction, but now it's actually considered a kind of a best practice to just use display array. It actually has kind of a more modern look and feel to the display array and the way the users can manipulate, delete data, scroll through the data than the input array. So keep that in mind when you're wanting users to be allowed to modify data in an array. The display array instruction has all that functionality too, and is actually has a better look and feel to it. More modern. So here we're defining an array. I guess the first thing to notice here is we've got two different sections to this PowerPoint slide, and that's because there's two different ways to define an array. We have static arrays and we have dynamic arrays. Static arrays, you can tell, they have a specific size assigned to them. So when you define the array, you specify how many elements that array can contain. So it has some drawbacks to it. One drawback is that whenever the program is executed, it automatically goes ahead and allocates enough memory for a complete array, right? Whatever size you've specified. Even if we don't load that many elements into the array, it still allocates as much memory as it would need for you to fill it up completely. So it may use more memory than is really required. The other limitation, and I know a lot of you have done some programming in 4GL, so you've probably seen that yucky array out of bound error. That's a really common error, and the problem there is we've defined our array as a specific size, like 5 in this example, and when we try to load that 6th element into the array, we get that array out of bound error, which is kind of annoying, but it's a pretty common error. So it doesn't have the ability to dynamically add structure to the array to add additional elements. So that's a static array. The other type of array that's more common nowadays is a dynamic array. And you can see here there's no size associated with the dynamic array. There's no theoretical size limit for a dynamic array. It's just based on the operating system that you're working with. So it can be very, very large. So it's very simple. We've got some built-in methods that we're going to look at in this chapter where you can just dynamically add elements to the array and add on to your array structure as you go, very simply. The other benefit to a dynamic array is it doesn't use any more memory than what is required. So until you actually add elements to the array, it doesn't use that extra memory like the static array does. So we talked about the different ways we could define the array, and there was two ways to do that in the previous slide. Well, now we see there's also two different ways here that we can load and display the data in an array. So we've got this concept of full list mode versus paged mode. So full list mode is the default behavior, and that just means that whenever you get ready to load the array, all the data from the results set, like you use let's say a cursor, for example, define a cursor, have some selection criteria for a database table probably, and then all the rows returned by that selection criteria are loaded into the array all at one time. So that's full list mode, and that's the default behavior. Just load the array immediately. So all the data from the results set is copied into the screen array, and the user then can scroll through the results set. Typically, this full list mode is fine if it's a pretty small amount of data. But one of the issues is you may not need all that data. What if it's 10,000 rows returned and the user's really only interested in like the first 50 rows or so? So you're doing a lot of network traffic, you're taking a lot of extra time maybe to do this select to pull back thousands and thousands of rows when we really never use them. So it's typically used just for short and static lists of rows, small amounts of data. Paged mode, on the other hand, is what you'd want to use if you were working with large databases, right? Page mode actually just provides the user with what we call a page of data at a time. And a page isn't a set value, right? It's not like 2K or something I could just tell you. A page is a very fluid and dynamic structure itself. A page essentially is just the amount of viewable space on the screen for the array. That can change, right? Like let's say we have a table container, we've got the form displayed up there, and at the time the form is opened and displayed and the data is displayed, that is a page, whatever size that happens to be. But then if the user, let's say, expands the window, right? Like he grabs the form and stretches the window, grabs the window and stretches it so that the form is expanded, then all of a sudden now we have a larger viewable area. And so that will trigger a special feature with paged mode that will go out there and we've got some special built-in functions that we can use to figure out how much more viewable space there is now that the user has stretched the window, and it will retrieve another page of data. And that page is calculated based on how much more viewable space there is and an offset, the offset into the rows and the number of rows that need to be returned to fill up this additional space. So a page can be different every time depending on whether the user uses the scroll bar or expands the window, whatever makes that viewable space larger. Usually the scroll bar, but he could also expand the window. So it actually just goes out and gets data when this special function is triggered because the user is scrolling through the data set and he's now gone beyond the last row in the viewable area, and that triggers this special function to go fetch some more data. So that's page mode. It's great for large amounts of data because it's quick, right? It comes back very quickly initially when the user, let's say, puts in search criteria and retrieves some rows. We don't have to wait for thousands and thousands of rows to come back to be displayed. So it's quick, and it also doesn't use any more bandwidth than is necessary based on his scrolling or expanding the window. So here is an example of some code that you could use to load and display the array using this full list mode, which remember is the default. All the data is loaded and displayed in the array at one time. So it looks like we're using here a dynamic array because I'm looking to see these special functions here are used with dynamic arrays. Is how I know that. So here we've got this function called show accounts, and here we're declaring a cursor to select some data from the account table. So here's a special built-in method in Genero, this account array dot clear. Right, so this is just our name of our array, and this clear is a special method that we can use to kind of initialize our array. So it behaves a little differently depending on whether or not we're using a static array or a dynamic array. It works on both, but it of course is doing something different. So if you're working with a static array, of course all of the structure for a static array is already allocated. So it goes out and sets all of these kind of pre-allocated elements that we have in a static array to null. For a dynamic array is basically, there's some structure there, but it's basically empty, right? Empty structure. So if there's any elements in a dynamic array from previous use of that array, this dot clear, this method that we have for arrays, removes all those elements. So essentially now you have this empty array. Then we use a for each. This is a for each that we're using with this cursor, this cursor we have up here called account cursor, and we're just using a for each to take the result set and load all of the rows returned from that result set one at a time into our array. So here we've got this special built-in method here again that we have to work with arrays in Genero to append an element to a dynamic array. It doesn't have any effect on a static array, right? It already has all the elements already allocated. So here's a function to add an element to a dynamic array, and then we're going in and just assigning the values of our program record that we've loaded this row into our array. And the way we've done that here is we've added an element to our dynamic array. We check this getLength built-in method, returns the current node in the array, right? The current element, like 3, for example, and then it assigns the values of our program record to that element of the array. So that for each loop just goes through the result set and loads the rows in the result set one at a time into this dynamic array. And then once we've loaded the dynamic array with our for each statement, we're ready to use our display array to display it to our screen record. That's using the full list mode. All the rows in the result set are loaded all at the same time and displayed all at the same time. And here we're talking about paged mode. So with paged mode, things work quite a bit differently, and we've got some additional methods to look at, some more built-in methods for working with dynamic arrays and working with paged mode. We get our database connection here, just like we normally would expect. We declare a cursor, and this is going to be a scroll cursor because we're only returning as many rows at a time as we actually need. So we need that scroll cursor to hold our place in the result set, right? So it's going to use a temporary table to do that. So we're going to use a scroll table so that we can maintain our place in the result set, so that if the user triggers this special feature called onFill buffer, this built-in clause or statement, then it will be able to find the offset into the result set by using this scroll cursor and returning some more rows back. So here we've got a dynamic array. This dynamic array is going to only hold one page at a time, and remember, pages aren't really a set value. It's just however much viewable space we have right now on the screen for that program array. So here's our display array statement, just like we saw with the full list mode. But here we've got this special onFill buffer, this built-in functionality to trigger fetching more pages into our dynamic array. So that gets triggered anytime that a user expands the window, scrolls, that will trigger that onFill buffer and retrieve more pages into the array. So let's look at the actual code for that. So here's the page mode. So here we're declaring the cursor. Here's our select. Looks like we're just selecting everything from the account table. So we're opening our cursor. And now that we've got our data selected, we're using our display array statement to display our array, program array, to our screen array. And this attributes clause right here, typically we'll have like a special count, like count equal 10, for example, and that determines how many elements are going to be displayed to the screen at the same time. Well, when we're not sure how many we want to be displayed to the screen or how many we have that we want to be displayed, like we would with page mode, we really have no idea what the viewable area is going to be. So what we can do is use this -1, which has special meaning that just says, when I ask for a page of data, just send me however much I'm asking for until there's not as many rows to return as what I've requested. And then I know that I've gone through all the rows. So that's what the -1 does. It just keeps returning pages of rows until there's not as many as what have been requested by this onFill buffer. So how many does it request? Well, it figures it out dynamically. Like, let's say the user scrolls. So it uses an offset and a number of rows, that's what this length is, to request additional rows from our cursor. So the offset, to get that, we have this special built-in function, FGL dialog get buffer start. So that's what we're going to use for the offset into the result set. We don't have to figure that out ourselves because we have this special function to do that. And then the length is how many rows we want to get from the result set for this page. And we can get that with this other built-in function called FGL dialog get buffer length. So those are built-in special functions, methods that we can use to get that information for a page of data. So here we're saying, okay, let the row equal whatever that offset value is, and for I equal 1 to length, which is that function that returns how many rows we want to return to fill up the viewable area, we're going to fetch absolute row from this cursor into our array. And then we're just going to keep implementing that until we get our page of data based on our offset and our length. All right, so input array, I mentioned we have a display array statement and we have an input array. Now the input array is what we used to use. It's a traditional method to allow a user to edit or delete existing rows as well as look at them. So the modified data is just stored in a program array, just like we saw with the input statement a little while ago. And then once the user's satisfied with his changes, then we go ahead and update the actual database table with what's in the program array in this case. So that's an input array. There's still a lot of input array statements out there. So input array, country array is the name of our array in this case, from sr country.star. And then attributes, here's our without defaults, because again we're allowing the user to input perhaps a new row, a new element into the array in this case. So we don't want to override what he's entering, so we're using the without defaults for that. And we're also using this unbuffered attribute. Remember that that makes the input array or the input statement, whatever we're working with, sensitive to changes. So if the user changes an element in the array through the screen record, through the form, then that has the effect of updating the program array underneath the covers in the code. And likewise, if we make a change to an element in the array programmatically, that will also update the screen record, right, so that it gets updated to the form. So that's the unbuffered, kind of a review of that. So the input array statement binds the screen array fields to the program array, right, to the member records, the matching member records of the program array. So again, for that to work properly, the number of variables in the record have to be the same as the number of fields in the screen record, and they have to have the same data types or at least have compatible data types. And that was true of just our plain old input statements that we've looked at previously. We've already talked about the without defaults and the unbuffered, so I'll skip over that now. So here's some predefined actions. We've noticed that there's several places with these interactive dialogues already that we've seen where we don't have to define explicit action views or actions for them to be displayed, right? We automatically get a lot of these default actions. So the same thing is true for input array, right? The input statement, we saw that we get the options there to insert, modify, and delete. Well, we get the same thing here with input array. So it's not really a new concept because we saw the same thing with the input statement. So we have a predefined action called insert. And again, if we don't explicitly define an action view for that, we'll get that push button, right, in the action panel that we're familiar with. We get a delete predefined action and an append predefined action. So we can override that, of course, by explicitly defining a toolbar item or a top menu command. We can do that, and then we won't get those push buttons. But by default, we'll get these buttons in the panel that we've seen a few times already. One thing I guess to notice, though, I don't know if I've really pointed it out. Now, these inserts, deletes, and appends, all they're acting on is the actual program records. In this case, it would be the program array and the screen array. These inserts and deletes right here do not affect the database table, right? So it's just working with the program array and the screen array. So it's inserting a new row before the current row in the screen array. And then field record gets put into the program array. But we still have to have that logic to take what's in the program array and use that to insert into the database table. So we'll see that as a separate step. So just like all these other interactive dialogues, input array has some control blocks that you can use to control the user's interaction with the form. We saw a lot of that in the previous chapter where we were doing things based on whether or not the user had selected the add option or the update option, the modify option. So you're familiar now that we can kind of force the user to move to a different field if we want to with these control blocks. Like, for example, we may not want him to be able to modify the primary key field, so we can use a before field for that if we like, and he's never able to get in there to try to modify something he's not allowed to modify. So we've also got all kinds of other control blocks. After field, we've got a before insert, before delete. So we'll actually see that here. Let's take a look at what we're doing here with this before delete. So notice here there's a before delete control block, and we're calling a function called confirm delete. And depending on what the user does or says in that confirm delete function, then we're going to cancel the delete operation. So here's using display array to enter and modify data. We talked about we have the input array, and that's the traditional way to let the user manipulate elements in an array, right? Was it the input array? But the last several versions of Genero BDL, we've been able to let the users do the same thing with the display array. And so here you can see the code we can use with the display array statement just to do everything, right? So the user can view the data, insert, update, append, and delete data with the display array. Very simple syntax as well. So here we've just got our display array. Here's our attributes unbuffered up there to display the array to our screen record. And then here's an on update clause. And notice the syntax for all of these first three are identical, right? So on update, we've got our input array, and here's one of these built-in methods just to specify the current line in the screen array, this array current. So whatever the user has highlighted here in our form is going to be returned with this array current built-in method. So input array, whatever the current line selected is, array current. And then from the current screen record that's associated with that. And then the on insert is exactly the same. The only one that's different is this on delete. And we've got this call to a function to make sure the user's okay with the delete, and also to do some checking. Let's take a look at that. It's, I think, on the next page. It's not on the next page. All right. Well, one of the things that you can do, for example, with this confirm delete function that they're calling here, might be to, for example, put in some SQL to go out there and look to see if this account has any orders, right, before we allow him to delete the account. So that would be a good thing to do with this confirm delete function as well. So you could call the confirm delete function. In that function, you could use the primary key of that account that the user said he wants to delete. You could do a select on the orders table using that user ID, and if there's any orders returned, then you could return back a message to the user that this account already has orders. They can't delete it, right? Or maybe ask them if they're sure at least, because you wouldn't want to create some orphan orders out there, right, by deleting the account associated with those orders. So that would be a good thing to check anytime there's a delete. Have some logic to take care of that. So this last page is just kind of a summary of some of these built-in methods for arrays. I think we've seen all of these in this chapter. They all look familiar to me here. Here's maybe we didn't see this one. Append element adds a new element at the end of a dynamic array. So you can use that to, of course, just add another element and then assign the contents of the program array to this element, or this element in the program array to this element. There's the clear method that we talked about earlier. Here's the method to delete an element, and then of course you're just passing it the index of the element that you want to be deleted. And of course if it's a dynamic array, it actually does delete that element at the given position, and then it moves up the other elements. And then get length, returning an integer. I think we saw that at one point in one of these functions, so that we could, I believe we were adding elements to the array and we're using the get length with a dynamic array so that we know what element in the array to assign the contents of the program variable to. So that was the use for that get length method earlier. Here's the insert element. Same thing here. We're inserting a new element at a given position in the array, so that integer determines the element that we want to make this new element a certain position, and then all the elements after this position are moved down. So that wasn't too long of a chapter there for arrays. And before we go over Lab 3, I haven't forgotten that we want to do that, but before we do that, let's go ahead and go over the lab for today first. We'll kind of get all of today's business out of the way, and then we'll go back and look at yesterday's lab. Bear with me one second while I drag that up over here. Take 4. Okay, so this is today's lab. This is the one we'd be working on this afternoon. So the first exercise, this exercise 1, is just an optional lab. So you don't have to work with the graphical debugger if you're not really interested in it. It's a long lab, and it's using the graphical debugger to explore the Office Store accounts application. So you can either work with this lab and explore that application with the debugger, or if you want to work with the debugger just on your own, you could use it to explore your own application. Maybe use it to try to figure out what errors you're having or problems you're having with your own application. So I'll just kind of put this out there as maybe a guidance for you. If you do want to play with the debugger, these are some things you could do to tinker with it. Exercise 2, you do want to do, it's our official lab, starting with exercise 2. Use display array to display a list of records. So you're going to create a new application node in your class apps group and call it display array. You're going to create another new form with the database form from Database Wizard. And there it's just walking you through what to select. And then connect to the database. Open a window and display the accounts list form. Display a menu with options to display or quit. And then a triggered display action should call a function to display a list of accounts. So here's all just some hints to help you with this display array. The function should define a dynamic array of record that includes members for certain columns in the database. Declare a cursor and use the for each instruction. So if you're not sure how to do that, you can look at the PowerPoints, right? Because I make a point usually of including in the PowerPoints examples of some of the things I like for you to do in the labs. So you can look back at the PowerPoints for that module to see how to define that cursor and use the for each instruction to fetch rows and add them to your array, program array. All right, and don't forget to add the library and database dependencies to the project. So if you have, if your form has been saved to a different node than your application node, then you always need to make sure you add that library node that your form has been saved to your application node as dependencies to the project. So we've seen how to do that a few times. If you'd like for me to show you again, I'll be glad to. You just have to ask. All right, so that's today's lab. It's not a very long lab if you don't want to play with the debugger. It's really just the display array, but it can take a while if you choose to tinker with the debugger part of that lab. So I'll make that optional. So the request I had this morning before I let you go was to look at the lab from yesterday. So let me pull this over here, close up some of this stuff so I don't get lost. Let me pull up that lab, day 3 lab. Okay. So yesterday's lab was to write an application to implement query by example on the accounts table. So the first step here, create a new application node in the class apps group named Q by E. Create a new form using the form from Database Wizard. You are going to select the Office Store database, the account table, all columns, and then use the default container, which is a grid container, and settings, right? So just use all the defaults for that. And then you're going to save the form with the name Accounts All and put it in your library node in your project structure. So let's take a look at that part first. All right, so there's our Q by E node that we added to the Class Apps application. We were supposed to create a form and store it in this library node. And the form, I believe, was supposed to be called Accounts List, and it was supposed to have a list of all columns Accounts all form, 4FD. Not sure that that really looked right there. That didn't look like the right thing. Oh, no wonder it's the wrong one. Okay, never mind. It's supposed to be Accounts all. For some reason, I'm having a real problem with form names this week for some reason. I'm not sure what my problem is. All right, well, there's probably my problem. I did not store it in the library node, so let me drag that down here. Notice if you don't have something where you want it in your project, you can just drag it, right? So I'm going to drag it down here to this library node, and now it's where it's supposed to be according to the lab instructions. I was supposed to save that to a library node. But now something I need to do is make sure that in this accounts application, this is what we were just talking about, I need to make sure that this library node now is included in my dependencies, right? So I've got my dependencies, my database is a dependency, database node, and my library node that has that form in it is a dependency. So now it should be okay. All right, so now I should have it here. That looks better. Okay. Pardon me. I'm doing that every day, it seems like, with forms. I can't remember the names of them very long. So here's the correct form. So it just has everything in it. All right, so back to the lab. So I'm going to unmute you, though, just in case I get to a point where you are having issues and you want to ask me to focus in on something. So here I'm going to unmute everybody. All right, and I'm just going to continue on with the lab. And if I get to a point where you have questions or issues, just go ahead and feel free to speak up, right? Don't be at all shy. All right, so here's back to the lab then. So I've got this form. I've saved it in my library node. I made sure that my dependencies included it already before I forgot. And then I'm supposed to, step 4, create a main module for the application named accounts-main.4gl that does the following. I need it to connect to the database. I need it to open a window and display my new form. I need it to display a menu with options that my user needs to query and browse account records. So I need a query, next, and previous, and exit. All right, so these triggered menu actions then, this query, next, previous, and exit, should call appropriate functions, but the functions need to be in a separate module. And then I'm supposed to save accounts main to Q by E application node. So I'm going to go down and look at this before we go back to the application. So that second module, it's what we're talking about here in step 5. I need a second source module called accounts-query.4gl that contains those functions called from the menu, and it should contain the following: a program record to hold account data fetched from the database, a function that allows the user to query the accounts table using a construct statement, and it's specifically on user ID, first name, last name, city, state, zip, and country. A function to prepare a SQL statement based on the string built by the construct instruction, and then I'm going to use a scroll cursor to scroll through that selection set or that result set. Declare, open, and scroll cursor. So you could have put that in the same function, or you can put it in a different function. And then a function to fetch the next or previous row into the program record depending on the action selected, and a function to display the data retrieved using display by name. And the user should get a message when he's at the end of the list or the beginning of the list. So let's take a look at all of that. We may have to pop back and forth to make sure we see everything. So here is, get rid of all this stuff. Okay, so there's my form. All right, so here we've got Q by E, here's accounts main. So here we've got our connecting to the Office Store database in our main. We're doing our housekeeping here where we're closing our window screen. And ignore this because we haven't talked about it yet. I'm going to get rid of that. That's for future stuff that we'll talk about tomorrow. So right here I'm opening my window with a form. And then here's my menu. So I've got this action for query, next, previous, and exit. And I've even added one here for close for good measure. So the on-action query here is calling a function called query account. So let's take a look at that. And remember, we've got that in a different module, accounts query, so I'm going to pop that up here. Here's where the query, accounts query is defining this program record, MR account record, just like the table columns. Here's function query account. It's got some variables here defined for working with the user, this continue OK. Here we've got an account count variable defined because we're at some point going to go out and check to see if our selection criteria that the user puts in for the construct returns any rows. So that's what the account count is going to hold, is the value returned for the count. And then here's our where clause. This all should look very familiar from the chapter yesterday. All right, and just disregard this part here with the window, the object. All right, so I'm clearing my form. Ignore all of this stuff because we're not using it. And here is the construct by name where clause, right, on these specific columns that I mentioned in the lab. And in here we're just doing some checking here to see if the user's used the cancel operation. We're assuming he hasn't. And if he hasn't, we're saying call getAccountCount, and we're passing this function, this where clause, so that we can see if he's actually put in selection criteria that returns any rows. So let's go look at that function. All we're doing here is doing a quick check to make sure it's a valid select. So here it is, getAccountCount, passing in that where clause from our construct and storing that locally in this p where clause variable that's defined as a string. And then, just like we saw yesterday, we've got our SQL text variable, which is also a string that's going to hold our concatenated SQL statement that we build from our where clause. So let SQL text equal, select count from account. Notice we don't need a cursor for this function because we're just looking to see if it returned any rows. So we're expecting only one row returned from this. So no cursor here yet. So select count from account, where, and then there's our where clause criteria. So we're just clipping all the white space off the end. It's not a valid SQL statement though, right, until we prepare it. So this is the part that actually prepares the resources, sends this statement off to the database server to be looked at, parsed, validated, come up with some sort of execution plan, whether or not it wants to use a sequential scan or an index, for example. And then once that part's done, then we can execute that statement. And this shortcut just says execute this statement into my variable, my program variable. So my count should be returned right straight into this program variable. And then I free up my resources from that prepared statement. So I'm going to return the count that was returned from that statement back to my calling program. All right, so that was right here. See, the debugger is very useful for this stuff, right? Right now I'm having to find where I was in the program before I went to that function, and I can get lost very easily doing that in a large program, but the debugger makes that very simple. It keeps track of exactly where you were, and so you go right back where you're supposed to go. But I believe I was right here, right, where we just call that get account count. I returned the count, and now it's saying, well, if there were no rows returned, then I'm going to return that message back to the user, right? So, oh, excuse me, if there were rows returned, if it's greater than 0, tell the user how many rows were returned. And then go ahead and call another function called account select and pass it the where clause. So we got two different functions we're using here. One for just getting a count to make sure it was a valid SQL statement and it found a corresponding row in the table. And then if it did, then we're going ahead and using this account select function to actually retrieve those rows. So now let's go look at that. Call account select. Where is it at down here? Hopefully I haven't already passed it. That's the problem with not using the debugger. Oh, there it is. I went right by it, I guess. Okay, so here's account select, and I passed in this p where clause, this string that has the results of the construct again. So here I've got stored that locally in a variable called p where clause, and again I've got my SQL text defined as a string so that I can hold the complete concatenated expression that will become my SQL statement here. SQL text equal. Here's my select statement that I want to use to select the data from the account table. And then here is my p where clause string that's been constructed from the construct statement that the user completed for us. So once we've built that SQL text, then this time we're going to use a cursor because we're expecting potentially more than one row from that select. Opening the cursor, and in here we're calling a function, fetch account, and we're just going to use that function to fetch the first row. All right, so fetch account is right here. We've passed it a literal 1 here. We can see here it's accepted here as a parameter and stored in a local variable p fetch flag. So if p fetch flag equal 1, which it was, right, we passed in the literal 1, then fetch next account curse into our program variable. So that fetches the first record into our program variable. Else, if it's not 1, then we assume it's going to be a -1, and we're going to fetch the previous row. Right now, though, we're just fetching the first row to display to the user. And then we're doing a case statement there to check the SQL code to make sure that was successful. And if it is, then we're going to return fetch OK to that calling function. All right, so I think that puts us right back here. We're back in our calling function, this account select. And it says, OK, call fetch account, returning fetch OK, and it came back successful. And then return fetch OK again to the calling function that called account select. And again, this is where the debugger is really handy. Okay, that puts us right here, right? Call account select, returning OK. If everything looked OK, then call display account. So now we've done our select, we've got a row retrieved with this cursor, and we're going to call a function to display it. See if I can find that. There it is. Very simple function, just the simple display by name mr account rec.star.